Okay, so last year we briefly talked about this. We used the roller coaster to tell us about the increasing, decreasing stuff. So increasing, remember our roller coaster? You guys remember that from last year, the roller coaster project? So roller coaster always goes from left to right. That's a very important part, left to right only. So increasing means that the roller coaster is going up, meaning you have a positive slope. So the roller coaster is going up from the left to right. Decreasing means that your roller coaster is going down, so it's going to have a negative slope. And sometimes you may have constant. Constant means that you have a zero slope. It's just cruising. Okay, so now let's take a look at the first example. So we have this roller coaster going up and down through this roller coaster. First thing that's going to happen is the roller coaster is going to go down, right? Until what point does it start going up? 1, 2. Okay, so when you're first doing this increasing, decreasing, if you cannot see it very well, please draw some arrows. So it's going to go up. And then what happens after that? Goes up again, right? Until what point? 5, 7, and then what happens? Goes down, okay? So this is the confusing part. Increasing and decreasing region has to do with the x values, not the y values. We don't actually care about how high it goes. We care about from which x to which x is it increasing or decreasing. Okay? I'm saying this because every year, someone will mix the x and the y together in their answer. It will probably happen again, but I'm just warning you. Please only check the x. Okay, so now we're going to categorize. First, the roller coaster goes down until 1, 2. Again, we're only looking at x values. So that is a decreasing. So from here to here, it's decreasing. How do we write that interval? Negative infinity to 1. Do I include 1? Yes, because there's a point. After that, I am going to go up. Until what point? 1, 2 to what? 5, 7. Because it keeps going up. So we just combine that together as one big interval. Okay, so from 1, 2 to 5, 7, how do I write that? 1 to 5, perfect. We don't care about the y's. We only care about x. Once it gets to 5, 7, it's going to go down. So how do I write this decreasing interval? 5 to infinity, okay? I know a lot of times it points down. You want to say negative infinity, but we're actually going in the positive infinity direction. Okay, so 5 to infinity. All right. Let's try another one. Again, my roller coaster is going to go from left to right. So roller coaster is here. What's going to happen first? Increase. And then what? It's going to have an infinite discontinuity and then it drops. And then my roller coaster all of a sudden starts down here. And then what's going to happen? Increase, okay? So this is where people get very confused. My line goes up and then all of a sudden it's gone. I don't know what to do with that graph that's below. Okay, it's starting to go up again. And then what? And then goes down, right? And then it's going to go down forever and then that roller coaster shows up back again on that side. And then what happens? Down again. Okay, so where that roller coaster disappears is very important because that's where it kind of stops, right? And then continues. So these are my asymptotes and they're very important for me to know where they happen. So first, let's write the interval from left to right. So it's going to increase. So how do I write the interval for this part, this increasing part? Okay, negative infinity to -1. And then what do I do on -1? Bracket or parentheses? Parentheses, because I have to skip this part. This asymptote I cannot cross. Okay, so that is negative infinity to -1, parentheses. And then what happened? My roller coaster shows up again. -1 to 0, okay? So this part, because, okay, hold on. Do I include 0? Yes. There's actually a point on 0. So this is the important part where because you have a vertical asymptote, yes, they're both increasing. You cannot combine it into one interval because you got to skip -1. -1 doesn't exist on my domain. Yes. So this is different from the first example when you increase and increase because it's actually, there's a point here. It does connect. So we can write it together as one big interval. This one, although they're both increasing, you're skipping over this asymptote because you cannot exist there. So you got to skip it on your intervals. Okay, after 0, -1, what's going to happen to my graph? Go down. So how do you write that interval? 0, 1, yes. 0 we're going to include. 1 we're not going to include because of the asymptote. And then my roller coaster shows up on the top again, and I'm going to start from 1 and then go to infinity. Again, what happens is my roller coaster goes from left to right. Okay, so your number should get bigger and not smaller. All right, let's try it. You're going to graph it on your graphing calculator. You're going to look at this, x plus 2 squared. Hopefully you kind of remember and you have an idea how this graph should look like. It is a parabola. What is the transformation? That way you can figure out the vertex because the vertex is going to be the lowest point. It's going to be where your graph is going to turn. So anyways, try that. Find the increasing and decreasing intervals. Okay, first. This graph, if you recall, this is just a parabola that's moved to the left 2. So this looks like that. And then increasing is from -2 to infinity, and decreasing is -infinity to -2. Okay, so on this graph, if you do want to figure out what is the lowest point possible and you cannot tell, this one is very easy to tell, but let's say you couldn't. You're going to do the same thing you did before. So you're going to go to second, trace, which gives you the calculate option. And now what you're going to look for is you're going to look for minimum. So we used to go to calc and then 0 to find where it crosses the x-axis. Now we're going to go to minimum because that's the lowest point. And you're going to do the same thing as you did before. Left bound, right bound, guess. And it's going to give you the exact lowest point. So you would tell it left bounds here, right bounds here, and then it's going to tell you -2, 0 is the lowest point. So kind of a tip for the future. For now, you probably don't need it. It's easy to see. Okay, number 2, increasing, there's nothing. Nothing is increasing. Decreasing is -infinity to -1. -1 to 2, and then 2 to infinity. How can you tell it's -1 and 2? You can always tell because your graph and your equation has to match. If you try factoring this, you can see that it's going to have that in the denominator, which tells you that there are 2 vertical asymptotes, which you should see on your graph. If you factor it, you saw 2 vertical asymptotes, but on your graph you only saw 1, you know your graph is wrong. Or there's something else you didn't see. But you can see that there are 2 vertical asymptotes, which means decreasing, there are 2 stops. Any questions? Okay, next. Boundedness. Okay, boundedness means can it go up? Can it go down? So we're checking the y directions. So we're seeing whether the graph is bounded in the y direction. So we're checking y values this time. So I've kind of put that note on the side to remind you, are you looking at the x direction? Are you looking at the y direction? Because there's a lot of things going on. Okay, so first, bounded below. Let's draw some graphs. Okay, bounded below means that there is a lowest point that my graph is not going to go under. For example, a parabola. Parabola has the lowest point, it's not going to go below. So that's called bounded below. There is a super low point, and that point is the definite lowest point. Okay, bounded above is the opposite. So there is a highest point that the graph is not going to go above. Bounded is the idea that your graph has a top and has a bottom, and then it's not going to go above or below. The last case I didn't write in here is unbounded. This happens very often. Unbounded means that your graph will just keep going up and keeps going down. Okay, let's kind of do that again. Bounded below means there is the lowest point. My graph is not going to go below. Bounded above means there's a top point. My graph is not going to go above. Bounded means I'm stuck top and bottom. It's not going to go past those 2. Unbounded means goes up and down forever. Good or no good? Okay, for example, so I always ask people this every year. Do you think I can grow any taller?
Yeah.
Oh, thank you so much. I have not grown since high school, I think. So I cannot grow any taller, right? So I'm bounded. I cannot, like, this is as tall as I can be, right? You guys probably can grow more. So you're not bounded. You can grow. Does that make sense? So like a plant, the roots can go below, right? So it's not bounded on the bottom and it's not bounded on the top. What else? No matter how high you jump, you can't jump over this roof, right? So you're kind of bounded here. Yeah, question?
So if I'm bounded above and below, is it like those graphs, so those graphs might go like, they're not going infinitely, they're like stuck at this point, right? Or
Yeah, so like if it's bounded above, it can keep going down. It just cannot go above. Like here, we can probably dig underground, but we cannot, I don't know, I guess if you try to shoot through the roof, you could. But if you don't want to go through the roof, then you're bounded above, but you can continue below. Yes? So we're only looking up and down, okay? Not left and right. Okay. Next. Let's have you identify. Is it bounded below, bounded above, bounded, or unbounded? Totally unbounded. It can go on forever. So graph those 2 and check. Number 1. Bounded below, bounded above, bounded, or unbounded? Bounded what? Below. Bounded below. Number 2. Bounded. Good. Now, before you erase those equations, we need to talk about lower bound and higher bound. Lower bound means the lowest y value. And then upper bound means the highest y value. So basically, okay, if it's bounded or if it's bounded below, what value does it's bound to? So for example, number 1, it's bounded below. So then we have a lower bound. So the question is, what is that lowest number? And when we say lowest number, we meant lowest y value. What is that lowest y value? Yes, -4. And you can see from this equation, right? That's just a x squared graph that's stretched by 3 and down 4. Okay, number 2, we said it's bounded, so that means there's an upper bound. And there is a lower bound. This one, you do have to check your calculator. Kind of scroll on your calculator, or you can use the second calculate button to figure out the maximum and the minimum, and then it will tell you what number that is. Okay, what is the upper bound if you found it? 1. It's not 1. I don't think it's 1. Yeah, 0.5. And what is the lower bound? Huh? No, it's not -1. Am I looking at the wrong graph? Huh? Yeah, -0.5. All right, next vocab. Local and absolute extrema. Okay. So what does that mean? It means where are the mountains and valleys of your graph? Basically, where are the highest point and the lowest point of your graph? And we're looking at mountains and valleys because sometimes they're not going to be super high ones. They're going to be hills, but we still care about them. So for example, maximum means the mountains. Minimum means the valleys. The difference is local and absolute. Local means the tallest mountain around the area. Absolute means the tallest mountain ever. For example, what is the tallest mountain around here? Huh? I say Mount Baldy. Do you guys know where Mount Baldy is? No. Okay. Anyways, it's the tallest mountain around this area. Is it the tallest mountain ever? No. What's the tallest mountain ever? Mount Everest? What? No? Alps? Alps? Wait, I thought Alps is like a region.
Oh yeah, me too. Wait,
There's like I think it's okay, the Alps are split into different regions.
I thought it was Mount Everest.
Okay.
Okay, let's have someone check and let us know tomorrow. Okay, so let's say Mount Everest is the tallest mountain ever. So then around our area, Mount Baldy is the tallest, but Mount Everest is the tallest ever. So that's the difference between local and absolute. Okay? Local minimum and absolute minimum, same idea. So the lowest valley around the area or the lowest valley ever. So really quickly, I'm going to make you kind of guess. So let's say you have this graph that's very strange. Okay, let's put some label 1, 2, 3, 4, 5, 6. Where is the absolute maximum? When I say where, I meant x value. Where is the absolute maximum, tallest mountain ever? Good, 6. Where is my absolute minimum? Where's my absolute minimum? Absolute, sorry, did I say absolute valley? Absolute minimum. Absolute minimum. There is none. My graph keeps going below, right? My graph keeps going down forever. So then what is 3? The local minimum. Okay, so 3 is not the lowest ever. It's just the lowest around that area. Then what about 4? What is this categorized as? Is that like a mountain shape? Is it the tallest ever? No, so that's a local max.
Wait, how do you know if it's an absolute minimum?
Absolute minimum means it's the lowest ever. It would be the lowest bound.
So there should be 2.
Absolute. So absolute has to be absolute, right? So there can only be one. Local can be many. Yeah. Yeah.